Okay, in the previous section we looked at sound. Okay, sound is an example of a wave. In this section we're going to look at light. Light is another example of a wave. However, they are very different. Really, about the only similarity between them is the fact that they are both waves. So let's look at the difference. Sound waves decide along the longitudinal, which means the vibrations are parallel to the direction of propagation of the wave, the direction the wave travels in. Meanwhile, light waves are transverse, which means the oscillations or vibrations are 90 degrees perpendicular to the direction of travel of the wave. Sound waves are mechanical. By that we mean they need a medium to travel through. Okay, sound waves is all about particles kind of bouncing into each other. Um, so they need something to travel through, usually air, but they can travel through water and solids and everything else. However, light waves do not need a medium to travel through. Yes, they can travel through water, they can travel through air, but they can also travel through a region of space where there's nothing at all. That's what in physics we call a vacuum, okay? So to think about it, the sun produces a huge amount of light, but between Earth and the sun, there's the nothingness of space, but the light can travel through that, and that's how we get light here on Earth from the sun. But you never hear the sun. And the reason you don't hear the sun is, yes, the sun's vibrating. We would expect it to be a source of noise, but there's no medium for those vibrations, those longitudinal waves, sound waves to travel through between the sun and Earth, so we don't hear the sun. Okay. Um, Sound waves travel really, really fast, 330 meters per second. That means they would cover a kilometer in about 3 seconds. It's huge. It's really, really fast, but it's nothing compared to light. Light travels at 300 million meters per second. That means it can travel from here to about the moon in 1 second. Um, it's the fastest anything in the entire universe can travel at. According to the laws of physics, nothing can travel faster than the speed of light. Light waves, certainly visible light, at least anyway, tends to have much higher frequencies than sound waves do. Okay, so there's many differences. You would be expected to learn those differences. Okay, so I would pay careful attention to them. The next thing we're going to look at then is what happens to light when it hits a mirror. Okay, now you might have done this experiment in year 8. We're going to review it quite quickly in year 9, or sorry, year 10. Ideally, you would be doing this experiment, and hopefully we will get a chance to do it in the future. But for now, I'm just going to draw a little diagram. You copy that diagram into your notes, and we'll describe what the results should be.